Okay, so today's what? Tuesday, March 19th. Okay, so today we're going to be looking at compound inequalities. What does the word compound mean? Presley?
Well, doesn't it mean like there's
It is a tough word to give a definition to. What do you say, Carson? Right? So we're combining multiple things. So often we'll think about, you can think about like you're compounding something in medicine, right? We're putting multiple things together and mixing them. Maybe the compounds, like you'll hear the wording of how we mix like cement or something like that, right? What our ratio is to water to the actual cement. You want a different compound based on the weather, based on some other things. Guys, headphones out, we're taking notes now. Okay, so that's what we're looking at here. Multiple things being put together. So here we're going to look at multiple inequalities that are being put together. And multiple inequalities can be put together in two different ways. The first one we're going to look at is that we're going to put them together with the word or. So this is even trickier. What does the word or mean? Presley? Well, we use it with inequalities, but just like in the English vocabulary, if we had to give a definition to the word or, what would we give our definition of or? Allie?
Isn't it like you pick one or the other?
So you're still using the word or.
It's so
Right, my students, that's the definition I always get. Pick one or the other. Right, this is where you get a choice. Choice A or choice B. Pick one. Out of two, pick one of them. Only one of them. Okay, so this is where we're sort of picking one. So when we're talking about a compound OR situation, okay, we're going to have two inequalities, and they're going to be attached with the word or, meaning that we have two situations that are okay. X can be less than 5, or X can be greater than or equal to 7. It doesn't have to satisfy both of those situations. It's fine if it's one or if it's the other. The problem that this is really hard to talk about what it can't be, and only is easy to talk about what it can be. So just like before, we'll use a number line to sort of represent all of those possibilities because it's just too complex to write down. We'd be writing for forever. There's more numbers than we can write down. So same as before, we're still going to make a number line. Again, good news, in the ALEX program, the number line's already made for you. I have no interest in you making a 42-digit number line. I just don't care. The only thing that matters to me is that you have the smaller number on the left. That's the only piece that matters, right? On a number line, smaller numbers go on the left. So I'm fine if you just put 5 and 7. At this level, I would hope we recognize that 6 is in between them. Right? Whether or not it's written there or not, hopefully we all recognize that. Okay, now this is going to seem a little bit goofy for right now, but I just need you to give me a couple minutes as we get through the class period here. We want to think about both of these. We want to think about both of these being graphed above the number line. So we're going to look at these individually. So I'm going to look at is less than 5. Open circle or filled in circle at 5? Open. So I'm going to graph above the number line because we're just going to kind of visually see what's going on. And are we going to shade to the right or are we going to shade to the left? Open or filled in at 7. So now let's look at the other one, right? Open or filled in at 7. Filled in, closed. And are we going to shade to the right or are we going to shade to the left?
Right.
To the right. When we're looking at compound OR, we are then going to graph any place on the number line. Our actual final answer is going to be anywhere on the number line that we see at least one of them happening, right? Because the definition of OR is pick one. So anywhere we see at least one makes it onto our final number line. Now, this makes me a little bit old, so maybe there's a better game to consider. But sort of think about this as like Tetris. Do we know what Tetris is?
Yeah.
And the pieces are falling. Okay, and we want to shade in anywhere the graph gets touched. Okay, so if the red piece is falling, what areas of the graph get touched? Right, all this area over here. So we're going to copy this down. Is a piece going to touch anywhere in the middle? No. Is a piece going to touch over here on the right? Yes. My students are like, Mrs. McKinney, that's the dumbest thing I've ever seen because all I did was just draw the same thing twice. Yeah. Yeah, that's what we just did. Just hang on to that for a minute. Okay, this would be our final answer. This shows that answers that do work are numbers like 4, 20, but not 6. 6 is not an answer. Okay? How about this one? 5 is less than W, or W is greater than or equal to 2. Which number goes on the left? 2. Was that a question, Lily? Yeah, so we're going to have to do some rearranging here. Right, we have to flip definitely to have the 2 on the left, but we also need to flip because we can't graph this unless the variable is first. Okay, so we'll rewrite this to have the W first. When we rewrite, is that a reason to flip the sign? Yeah. Yep, sure is. Open or filled in circle at 5? Open to the right or to the left? Right, because we had to rewrite it. Open or filled in at 2?
Filled in.
Filled in. To the right or to the left?
To the right.
To the right. Our final answer is going to be anywhere that the graph gets touched at least once. So is the graph getting touched over here? No. Is the graph getting touched in the middle? Yes. Is the graph getting touched over here? Yes. So our final answer is just that. It's way easier to talk about just this than it is to talk about the entire compound inequality. Okay, you do not need to copy down the filled in circle again Because the green line takes care of that. That's why we always graph above. There's another reason too, but that's one of the reasons why we always graph above. Okay, we're going to look at one more here. Still compound OR. I mean, it's kind of hard to miss that it's compound OR if there's two inequalities, which was the word compound. And it's a compound OR because we see the word OR. Okay, so what are we going to have to do with each of these inequalities first? Just solve them. Right, these are basic one steps, just solve them. So we'll undo adding 5 by subtracting 5. Okay, how are we going to solve this one over here on the right? Divide. What happens when we divide by -2? We have to flip the sign. What's 36 divided by -2? Right, so obviously the more efficient we are at solving, the easier it makes it to get to the piece where we're graphing. Open or filled in at 7? Open. To the right or to the left? Open or filled in at 18?
Open.
To the right or to the left?
Right.
Okay, and then our final answer is anywhere that it would get touched at least once. So is the graph going to get touched over here on the left? Yeah. Yep, sure is. Is the graph going to get touched in the middle? Sure is it. How about over here on the right?